The topic that we are discussing right now is the relationship between force and momentum. For your consideration, I need to explain what is the force. Most of you know that it's an agent that produces a motion in a body, or at least tries to produce a motion, or it stops a moving body, or at least tries to stop that body. And what is the momentum? Yeah, you are right. I think most of you knew the definition of momentum. It's a quantity of motion in a body, and it depends upon two quantities, that is mass of the body and velocity or speed of the body. So force and momentum, what is the relationship between these two values? In order to drive this relationship, we make a supposition that a body whose mass is m is moving with an initial velocity vi. So you know that if a body has some mass and it is moving with velocity vi, it possesses momentum in it, which is the product of these two values. Now, if a force F acts on this body, so what will happen? It will produce an acceleration in the body. Thus, it means that the velocity of the moving object will increase, which will be its final velocity Vf. So, after applying a force F, the body is moving with a velocity Vf. Now we can write the initial momentum of the body when the force was not acting on the body, that is, momentum is represented by P, and this is initial momentum, which is equals to the product of the mass of the body, which is unchanged, times the velocity of that body is Vi. So this is initial momentum. What happens when the force F acts on the body? It produces an acceleration and changes the velocity of the body from Vi to Vf. Its velocity is increased by some amount, so its momentum will become as final momentum, Pf. Place a subscript I and F for initial and F for final momentum. You can write m, the mass of the body, times velocity of that body is Vf. So can you tell me that what momentum is bigger? This final momentum is bigger because mass is same, but the velocity, final velocity is greater than initial velocity. So the change in momentum will be final momentum minus initial momentum. On the right, on the left hand side, similarly you can write on the right side, mass times Vf, final momentum minus initial momentum. Now this all thing happens in a certain period of time t. So if we divide the whole expression by t time, Pf minus Pi divided by t is equals to m Vf minus m Vi divided by t. That is the rate of change of momentum. You can write it as Pf minus Pi over t, taking m as common. This becomes Vf minus Vi over t. This is the rate of change of velocity, and you know that the rate of change of velocity is acceleration. As we know, acceleration is the rate of change of velocity, that is Vf minus Vi over t. So in place of Vf minus Vi over t, we can write acceleration. So this equation becomes final momentum minus initial momentum over time t is equals to m times a. Let's suppose this is equation number 1. And you know that from Newton's second law of motion, whenever a force acts on the body, it produces an acceleration in its own direction, which is directly proportional to the acceleration of the body and inversely proportional to the mass of the body. So the mathematical form of second law of motion from Newton's second law of motion, you know that F is equals to ma. This is equation number 2. So you see that equation number 1 is Pf minus Pi over T is equals to ma. This is equation number 1. And equation number 2 is F is equals to ma, equation number 2. Comparing both the equations, comparing 1 and 2. So you see that on the right hand side of both the equation, it's a term ma. Whenever we compare the two equations, the expression which is in both the equations, we leave it or we eliminate that expression. So in place of ma, we can write that if the right hand side of these two equations are equal, it means that left hand sides of these two equations will also be equal. So you can write Pf minus Pi over T is equals to F. Here comes the relation that the rate of change of momentum or the difference of momentum with respect to time interval t comes out to be 4 equals to force which acts on the body. This is your required derivation for this relationship, force and momentum. Take care of yourself. Bye.